Government Engineering College, Chandkheda, Ahmedabad, under CT Gandhinagar in Government of Gujarat. Dr. Trivedi's research interest is futuristic power system and economics and power electronics. So I welcome again, sir. Now I am handling session to you, sir. Thank you very much.
Okay, thank you very much, and good morning to all of you. It's heartily welcome to the lecture. Before I start sharing my slides and everything, I would like to make clear that this lecture is intended for technological challenges basically. Technological challenges when we are going to adopt the electrical vehicle, but at the same time my basic concentration will be for the persons who are researching or just initiate to research in the field, because you know electrical engineering is a vast subject where we are sharing number of research areas. So it might be that my research area is somewhat different. It's a futuristic power system and economics related with it. But at the same time, when you say that it's a future electric power system, definitely it will be containing of a number of things. You know, smart grids will be there, new mechanisms will be there, new vehicles, and God knows after 10 years what will be there. So that should be kept in mind while attending the lecture. Second, that we have got number of papers, slides, and many things. So every researcher knows that they have the basic references and number of slides, because nowadays it's very easy to have the slides and knowledge as far as net and everything is concerned. Plus e-subscriptions are going on for each and every journal. So try to concentrate on the speech which I will be delivering to you. It will give you some glimpses not only on the core electrical engineering or core EV, but it will be containing the macroeconomic factors, microeconomic factors, and the technological advancement and challenges, or you may say barrier in the development of EV. So that's my request to the whole participants, that try to concentrate on the talk rather than the slides, because if you want, I can share my slides to the coordinator and afterwards this can be shared to you. But talking to each other online every time it is not possible. So please try to understand this thing. And my point of concentration will be the researchers in the area. So I think I have cleared my basic aim. Now just give me 2 minutes. I will be sharing my screen to you, and with slides we will be keep on moving. Yes, it is little bit clumsy, but as you can mark, the FDP is organized by ADIT, AICT, and myself, I am from VGEC. See, the technology always is not a pure, right? Many times it happens that technology is always connected with the history and time frames. So history of vehicles development that I have shown here starts from 17 69 onwards up to 2000, and now we are running in 2020. So every decade you can mark the eras are different and priorities are different. In fact, history starts from, as far as electrical engineering is concerned or pure EV is concerned, history starts before the steam engines and everything. It was the war of wires. DC is good or AC is good. And then it was a business rivalry, and one has win and one has lose. Again, we are in same dilemma and confusion. So at the era of today, again we are thinking DC is good or AC is good. In that connection, we have started to use DC for our purpose of electric vehicle. So it shows that DC is always beneficial, but still it's a matter of confusion. But as far as EV is concerned, definitely DC is fine enough. Only the thing is 40% of the vehicle weight that we are sharing with goes to the battery. And I think battery is the main problem, because more and more research concentration was there in middle time, starting from 1900 onwards, I think. That was given to the machines, because at that time power was needed. Nobody was thinking how to store the power, but at least generation of power was important, and that's why people have concentrated on machines much. So machines were developed, generators were developed, motors were developed, and then people have think of how to store the electrical energy. From that onwards, the battery utilization started, and once it was started, it was utilized by the different business pockets where weight was not important. For example, plating and different applications are there as far as batteries are concerned, but we are sure that at that business pocket, weight was not important at all. Nowadays, we have started to think that, okay, we have generated electricity, some means are there by which it is being stored, or it can be stored and later on it can be utilized, and same thing happens with the battery. So now battery weight is coming to the main concentration, and I think that is the biggest technological challenge as far as electrical researchers are concerned. Again, it's not a pure electrical research, but you may say it's a electromechanical and electrochemical research or material science, which plays the important role, because we are the end users of the battery, and the research area for the battery and what we are thinking of. So, for example, lead acid battery was there. It was running very nice, but again weight was more. Then we have transferred it to lithium-ion batteries, and still performance of that is far better than the lead acid battery. But still, you know, as I have cleared that 40% of the weight of the electrical vehicle goes to the weight of battery, and that is not favorable by any means. So still, number of teams around the world is researching on the new material to make weight less as far as electrical vehicles are concerned, and particularly for the battery. But still, great success is far away, God knows, and we hope that within very short time we should hear the news that new material has been invented that can give the weight and power ratio of battery in a larger way. So that's all. I am not discussing whole the history of vehicles, but as far as EV was concerned, I think battery was needed to be discussed. This is just mere outlook as far as India is concerned. Second thing, I would like to tell you that as far as India and rest of the world are concerned, technological challenges more or less it is same with India, but in the way in which we are looking to should be different. For example, if a country like Switzerland, Denmark or Poland is there, they are very small countries. Atmosphere more or less is same. Okay, atmosphere, what does I mean? That atmosphere has got vast meaning, but I am keeping temperature lines into my eyes and logic. So if temperature line is to be considered, their temperature line is unique. Okay, as far as India is concerned, we are on the specific place on the earth where crossings are different, our horizons are different and vertices are different. So we have to think in that way. They're starting from Kashmir to Tamil Nadu. Your temperature range from Kargil to the Kanyakumari goes to very high transient. It might be minus 29 to minus 7 or 10 or 12 at the Srinagar, and it in middle, if you consider 45, 42 are the temperature range. Again, it is being lowered when you are moving to the sea coast. Same way happens with the east and west. So you can study the whole temperature spectrum of India. And as far as India is concerned, we should think in the research corner where India is to be in the focus as far as electrical vehicles are concerned. People are afraid of, people are fearing of just now that they are sitting on the chemical bomb, which has got limited capacity to drive, but major capacity for the blasting and everything. So that is our mindset, because whole world is agreed to it, but their temperature ranges are different. So that fear is not that much, but our fear is very large. So I request the new researchers to research the field in their own way, but there should be Indian angle in your research, because geographically we are very vast, and as far as temperature spectrum is concerned, our needs are different. Again, population is 125 lakh crore. So depending upon the population, different technological changes will be there, and you are required to accommodate those changes as far as populations are concerned. Now, how it affects, because population is more, so you have to be uh, constraintful in the sizing of electrical vehicle. It should be narrowed and not too long, and that is not the requirement of rest of world. Okay. So these are just the points, and what slide shows is the outlook only, that what government of India is thinking of. Government of India has given FAME 1 and FAME 2, and they have came out with 10,000 crore at the time of FAME 2. Okay, and at present our need is to increase the charging stations. The charging stations includes the charging infrastructure. So we have to think of that. In one way we are talking that non-conventional energy sources should be maximum as far as Indian grids are concerned. And in that, as a load, you are having your charging infrastructure. So what happens to the voltage, current and power quality, that should be the important to us. At present, of course, nobody is thinking of that, but in future it will be highly precious and highly needful to study these factors, because at present we are thinking of and we are worried for infrastructure only. So things are going on in this way. Okay. So try to concentrate on the research themes, those who are based on the sizing of EV. Sizing means I am talking about the physical sizes, whether it is to be utilized within city or within district or statewide, intrastate or interstate. And depending upon that, the basic sizes should be standardized. And for that, you again, battery will be in the major role. And as far as your designs are concerned, it should be matched in line with the sizing. So I think that is the main point of concentration where technological challenges lies. So that was point number one, that was battery. Second is the styling or designing of the EV itself. Next, this is Gujarat EV Policy. Government has came out with the roadmap. Subsidies are given for 2-wheelers, 3-wheelers, 4-wheelers, and government is planning to have 500 charging stations, but currently 278 charging stations in location. Still, it is not enough, but in a big way. I think permissions will be given to IOC, BPCL, and Nayara, that is SR previously. Charging infrastructure, normal charging stations and fast charging stations. So this taxonomy easily you can understand by searching Google, and later on it can be cleared that what does it mean. Okay, again, type of end users are defined, whether it is individuals or commercial or government. In some state, government or state government itself is forcing for the electrical vehicle as far as their government contracts and government vehicles are concerned. So that's all about the techno economy, and let me limit it for technology only. Again, this is overview. Different vehicles are there, different charging infrastructures are there, difficulties and roadmap of EV and optimization technique. So I think last two are the more concerned with the technological changes or barriers in EV. Different vehicle, it means the HEV, PHEV and BEV. Again, in HEV it's a series parallel or power split model. And as far as charging infrastructure is concerned, business models are there and EV policies are there. So both has to go in parallel as far as charging infrastructure is concerned, because only government can't do it. Government should frame the policy, and dependent on that policy, the business models will be running, and further the infrastructures will be improved. Now, what are the difficulties in roadmap? Roadmap, as you know, it involves the four factors very clearly: market, technical, policy, and infrastructure. So our point of concentration should be two only. And of course, one, because what sort of market is going on, that I will discuss later on. But policy and infrastructure, that depends on the government willingness and government policies. Some regulating authority will be designed, and I think things will be moving on in order. As far as last is concerned, it's the optimization technique. Now you should concentrate here more, because vehicle to grid optimizations are needed, design optimizations are needed, converter design, battery design, and charger design. Again, recycling should be included here, that if you recycle in a one way or other way, what should be the optimization parameter and what should be the technique by which you are recycling. So I think that is not written over here. But as far as vehicle to grid technology is concerned, easily you can think of, now you should connect your first point to the first point of last one, that is market. EV market is different thing. I'm not going to discuss the EV market, but as far as vehicle to grid is concerned, it's a bilateral scenario. You know, when you are driving your vehicle, you are utilizing your electric power, and when you are stopping it, parking it, and you are doing your functions as an individual, your vehicle feeds back to the grid. This is the current scenario as far as European markets are concerned and US markets are concerned. So again, you are feeding to grid means your vehicle is earning something, operator or supplier of the electricity pays you back. And for me, that is the market as far as future models of EV is concerned. Of course, it is available just now because we are using converters and inverters. And as you know, that if you have a battery, you are using inverter and feeding back to the grid. So it's a bilateral scenario in which your vehicle should work, and much research is needed as far as grid connection of EVs connection is concerned. Second thing, electric vehicle design. So I think basic block diagram is clear to everyone. Very less design aspects as far as technology is concerned is to be needed to concentrate upon. First thing is vehicle sizing. Second thing is the design of converters and inverters, or converters. In a simple meaning, you can say converters. And then protection will be there for design. And one more thing that again concentrate to battery itself. So these are the design parameters, and optimization goal should be the different. Either you take efficiency, either you take weight energy ratio, or you may take vehicle pricing, initial pricing of the vehicle, or you can set up with the future market or the price mechanism with it, and then you are optimizing the things as far as designs are concerned. Again, converter design is there. As you know, converter design is the research topic which is favorite from 1940s. I think before that also you will find many papers. But after 1940s, it has came into larger way, and still people are researching. But now people are concentrating on the material itself from which the converter devices are to be manufactured. So like semiconducting material was there, and then whole family is there, thyristor family and different things. But now people are ready to change with the material. If you get the higher performance, the new materials are being tried for converter, and how much design improvement is there, how much performance design is important, that people are seeing with help of optimization. This is what we have discussed, battery design and charger design. Battery design we have discussed, charger design is a different thing because it's the electromechanical design, and as far as standardization is concerned, just like electricity, if you move to the different countries of the world, you will find different plugs and different supply levels, even different frequencies. So I think one country is there in which half of the country is running on 50 years and half of the country is running on 60 years, and still they have the interlink between 50 and 60 hertz, and things are moving in a smooth way. So charger design, I think it is a problem of standardization. So universal chargers are available. So if you put your vehicles in charging in India or Europe or US, there should not be any concern as far as connectivity is concerned. Second thing, electromagnetic interference is playing important role as far as chargers are concerned. So again, that is to be looked out when you are doing your basic optimization. Again, this is in form of obstacles. Market means a lot, service initial cost, owner's thinking. Third is important one, owner's thinking, what we are calling the mindset of a owner. Fourth is the material. So material science plays the important role as far as EV is concerned. This material is different because they are talking about the material market. It means the steel market and battery market, everything. But the material in my mind or logic at present is the material which is utilized to manufacture the batteries and converters. Technical effectiveness of the battery, mileage, range of EV. Second is most important, that is to be think of time taken for charging, safety concerns and environmental effects. So I think we will not be dealing with first and fifth, but mileage range of EV is again debatable, and it's a big technical issue because maximum allowed is the 300 kilometers. So if you move beyond 300 kilometers, what will happen? For that, either your vehicle should be hybridly designed. If not, that at the end of 250 kilometers, you should be having the facility of battery swapping. If it is not there, that your regenerative braking and non-conventional energy sources which are mounted on your vehicle itself can help you to extend the mileage range of EV. Just you can think of, no, if your solar rooftop is there and domestic wind generating devices, wind power generating devices are mounted on your vehicle and you are using it effectively, then mileage can be increased by 10% or 15%. It will not be quite helpful to you, but it's like a buffer stock for your mileage, and that can be considered at the time of design. Time taken for charging, again, this should be the issue. But as you know, in present era, time is the money. If you want to lapse less time, you have to pay more. If you are free and your time is available, then the cost should be reduced to you. So whether you are stopping for 6 hours for charging or you want to stop 6 minutes for charging, that should be the deciding factor, that how much time you are taking for charging station, and charging station is charging you accordingly. Whole thing is digital based, so we should not worry. While drinking a tea, the bill will be available to you or charging conditions will be available. Fundamental is true that time is always related with money, and that should be optimized when charging. So fast charging, moderate charging and slow charging are available to you, but how to make it more fast, that should be the technical challenge, and any researcher can go with this, because ultimately it's a part of optimization, that how much, what is the charging cycle, what are the parameters, what are the insertion of non-conventional energy sources as far as pricing mechanisms are concerned, and it decides your overall time and overall pricing for your charging. So any of the parameter you can take, and you can have the review papers based on that. Fourth is the safety concern. That was my worry, and earlier I have discussed that we are moving in a big temperature spectrum. So safety concern against temperature is becoming the hottest issue. And second thing, protection, which is related with your EV. Because whenever you are using electricity in any form, protection will come into picture, and sophisticated protections are needed, precise protections are needed to stop the uh, the big things to be moved on as far as your standardization is concerned. So in that standardization, the protection of EV is becoming more and more standardized nowadays, that we will see later on. Fifth is the environmental effect. So if any researcher is interested in this, this is the vast area, and that can be researched as far as utilization of EV is concerned, because in a big way it affects the environment. But as far as the whole life cycle of EV is concerned, again it is questionable. Of course, environmental factors will be preserved, but when you are discarding it, when you are discarding the battery, when you are recycling the battery, or you are recycling your vehicle itself, what is that impact in the future on environment? That is to be seen, because it's not a 100% clean vehicle. At present it might be, but in future when you are discarding it, and the battery itself, when you are discarding it, it gives some bad environmental effect, and that assessment is to be made. Otherwise, how you can say it's a 100% clean energy, or 100% clean vehicle, or 100% clean air? So always your future discarding of the electronic component is becoming nowadays big challenging task as far as whole world is concerned. As you know, computers are being utilized, but how to discard the electronic waste from which is generated from computers is again remains a question. So now it has become more technological challenge, that how to discard the computer. Reuse is different, recycle is different, and if you are discarding as a whole, that might be the different. So that sort of impacts are to be considered when you are considering the technical challenges. Again, I am not discussing the Indian policy and infrastructure. This is macroeconomic environment. I think we have discussed this all in the details, but just to narrow it down, that it's not only EV, but it is connected with political, economic, social, technological, and legal factors. So how to take technological challenges, it depends on the utilization of EV. And again, utilization of EV depends on the solution of these 5 macroeconomic environmental factors: political, economic, social, technological, and legal. If political will is not there, forget about it. Some people will be using EV as previously it was being utilized. Nowadays, our concentration is more because of economics and environmental factors. That's all. Because EV were available since long, and now people have started to think about it due to the fossil fuel prices. So after 1950, your diesel and petrol vehicles might be in museum, and you will be using different sort of transportation means. So that is to be considered, and it is equally important. If you see legal framework, or technological framework, or social framework, or any of the things, political or economic, it is equally important. If you give zero weightage to one, other 4 cannot survive alone. Economic consideration, more or less, we have discussed. The point of concentration here is the TCO. Okay. So how to deal with the batteries, that remains a big question and big technological challenge. And possible solutions are separation of ownership of battery from vehicle. TCO model being offered by the manufacturers and battery swapping. So you don't have to worry, you have to swap the battery only. And when it is to be discarded, the last time what price you will be paying, that should be the different. These are the models of separation of ownership of battery from vehicle. So I think much is understood by the everyone. So I'm not going into the detail. This is TCO. So if you have a look inside, this is a model of ownership. And this is from Revolt plan of total cost ownership. So if you look at the upper figure, it's a many things connected, and that should be considered while you are considering the TCO. Revolt has given some good schemes and good thinking as far as this line is concerned. So if you are interested, you may think it out. This is battery swapping. Again, it's like upgrading your computer or giving your computer back and purchasing new. Like if you are knowing in foreign countries, if you are discarding any sort of electronic waste against your older one, then you have to pay for the older one and then you can purchase the new one. Or if you are giving back as it is, then it's a responsibility of basic manufacturer to make it discard. And again, it will cost to the manufacturer. Again, in turn, your product will be more costly. So battery swapping has got simple meaning, but if you go into the detail, basic charging phenomena, that should be the real technological challenge, because you have different capacity batteries. You have to charge all the batteries within available time, and how to give supply connections to that battery to make it swap compatible. That is a problem of optimization and technological challenge, and that's why I have included battery swapping over here, because 5 to 10 minutes you are saying, but it is mimics. How much time, how much power is to be consumed by the particular battery if you want to get it ready for swapping. That story is technological story, and that is altogether different. Now these are the other technological challenges. In infrastructure, if you see, the availability is the main factor. Type, whether it is AC/DC or fast, or you may say that speed of charging. Standardization of connector, that's what we have discussed earlier, that different charging sockets are available and that has to be made standardized. Connectivity of green grid. So these are the beautiful words, but behind every word there is always technology connected. Green grid is a beautiful word, smart grid is a beautiful word, microgrid is a beautiful word. But if you look beyond as an electrical engineer, in what is inside in the depth, you will find many technological challenges are lying there, and that should be researched upon. Those are the research points or new research points as far as grids are concerned. Because I will take 2 minutes offline and to the off direction, because if you are knowing, we have started generation of electricity first. It was started with DC, then AC was preferred, as I told you in starting of my lecture, that more or less, if you think, the war of wires was there, and then we have prepared the small grid. Okay. Now, people have think of that if you are interconnecting grid, it is beneficial. Then people moved upon, researched upon, and models were prepared where nowadays we are connecting countries with countries as far as interconnected grids are concerned. So we have enlarged the grid size. Again, due to many issues like blackout and reliability of the supply, synchronization of the supply, again people have think of that no, it is not that much beneficial. That again matter of splitting was in picture, that we should split a grid in such a way that reliability should be more. Then again we have splitted our grid into different parts, what we are calling distributed generation, or any beautiful word will be there as far as electrical engineering is concerned. But ultimately you are splitting your grid again to make it more reliable, to make it more business friendly. Because when you are talking about the reliability, definitely it goes to the price, that reliability level A, B and C. All the three customers are paying you different prices. So again, we were in the era of microgrid, which was in existence before invention of AC even. So again, we have moved to the microgrid, hybrid, then nanogrid, and now we are talking about the smart grids. And this is a word which you are seeing here. It's a green grid. Altogether, this all has got different meanings. But ultimately what we have done, what was there in the starting, we are adopting it again with newer words, beautiful words with more reliability. So I think reliability is the main technological challenge as far as EV designs are concerned. Try to remember my sentence, that reliability will be of the prime importance as far as your EV is concerned and your charging station infrastructure is concerned. Okay, so that's all about the charging infrastructure. Then the question of batteries is coming in a big way, or you may say challenges of batteries are coming in a big way. First thing is standardization, how to make standardization of batteries utilized for EV. Keep in mind here, everything we are discussing is regarding the technological challenge of EV only. So batteries utilized for EV should be standardized, and it should be the international standards, not country-wide standards. The battery chemistry, this is altogether a new challenge, but more or less the technical person who understands the chemistry will be more useful. Indigenation. Now this is what we want to adopt. You may say Atmanirbhar or Atmanirbhar Bharat or any government policies, that the things which you need, you should manufacture itself in your own way, in your own country. And disruptive innovations. Again, it's a challenge that innovations are going on, but it is going on in a part. In fact, it should be sequential. If you are having sequence of innovations that can be connected together, it will give you definitely the big output as far as EVs are concerned. So that should be taken as a challenge. Current areas of research. Now, if we want to focus on any of this point, I think 2 hours will not be the sufficient, but just to narrate upon the energy storing system. This is of prime importance as far as power system is concerned and as far as EV is concerned. Same way, power electronic system, when you are utilizing power electronic system, Again, it goes to the grades of the components, reliability of the components, reliability of your circuit itself. Okay, and the nuisance which is created in the basic grid by the power electronic system is to be cared upon. Try to understand the word that you have to utilize one device. Now that device is creating nuisance in your basic power system, and if your grid size is small, easily it can harm your smart grid or microgrid. So this is to be concentrated upon, because ultimately it's the essential part, you cannot remove it. But when you are inserting it, there is some nuisance, and that is to be cared of. So sufficient devices are available, but again it is to be researched that why it happens and what is the mitigation techniques for it. So power quality monitors are available to you. Power quality mitigators are available to you. Mitigating techniques are available to you. And whole the area is altogether different as far as research is concerned. Drive system. So ultimately you have to drive the electric vehicle. For that, drives are important. In drives, the basic block diagram is known to the every participant, I think, that when we are talking about the drive itself, then what sort of drive it is, what is the performance, what is the efficiency, what is the outcome, what is the power quality parameters, what are the reliability parameters. This is to be cared of. Vehicular dynamics. Now this is true starting from electric vehicles or any vehicles up to the Boeing companies, that different optimizations are needed as far as vehicular dynamics are concerned. So I think it's a different research areas, and which is not pure electrical research area, but still it is equally important as far as the designs are concerned. You know the basic railway systems in which we are using bullet trains and maglevs. So you can see easily that what ultimate dynamic shape they are adopting, and that should be concentrated upon if you want to have the research in the direction. But ultimately this optimization is to be done with vehicular dynamics. Development of charging infrastructure. Again, it is to be simply understood, as we have discussed a lot earlier. I have discussed a lot earlier regarding this, and still further we will be discussing. Smart and connected vehicle. As I have told you earlier, that vehicles are electric vehicles particularly are utilized bilaterally to earn the money and to spend the money. And that is what is narrated here in technical language, that is smart and connected vehicles. In fact, automated vehicles will be coming very short in a way. You will find autonomous vehicles also as far as EVs are concerned. See, drones are available to you. People are much researching on the automated or autonomous vehicle, including the buses itself, city buses itself. And people have tried also. In fact, in 1 or 2 countries, they have tried successfully in a public with the autonomous vehicles. So definitely this is good research area where the autonomous techniques will be coming into the picture. So not only smart and connected vehicles, but autonomous vehicles are also part of it. And if you want to have the research topic, you can go through the literature and start of your own. Now this is R&D required for the EV subsystems. So just you can see the points. Those are the points which is elaborated in a way you can connect it to the previous heads of the technological challenges, that drivetrain, motors, controllers and distributed motors, reduce kilowatt per kilometer power uses, DC to DC converter, battery chargers and battery swapping systems, electrically driven power steering, power brakes and air conditioning. This is, you may say that power brakes includes the regenerative braking also. The battery packs and battery cells, lithium, manganese, cobalt, nickel. So many chemistry parameters are playing their important role. Material weight itself. Okay. And further you can have a look at it. Materials for better insulation, air conditioning, and better tires and better aerodynamics. Vehicle controller software and integration. This is important as far as digital technologies and digital controls are needed, or autonomous controls are needed if you want to connect your vehicle to the smart grid or smart nano grid. And future technologies. Future means we may consider within next decade. It will not be the future, but actually available technologies. At present also, hydrogen fuel cells are available to you. And battery chemistry handling 45 degrees centigrade, grid integration. So more and more technologies will be coming into picture. IoT will be coming in a big way, and we will be utilizing it. Cloud computing and cloud utilization as far as your autonomous vehicles are concerned, that is to be researched upon. But once electrically you are finalizing, electrical design you are finalizing, then rest is the digital technology, digital economics, and cloud computing or cloud surviving of vehicle, including GPS and everything. That should be the cover area of future technologies. Now this is need of standardization. Why it should be standardized? So these are the points. I am not reading these points, but you can note it easily. That onboard charger properties to the vehicle and need not to be standardized. Offboard chargers needs some minimum standardization so that any electric vehicle may be charged by it. So some factors are there. If you are not standardizing, nothing happens. But some factors are there that must be standardized, and standards should be compatible to more or less every countries which are using the electrical vehicles or electrical vehicle policies are going on. This is need of standardization. Limited standardization is available as far as today's era is concerned. Okay, so connector standardization is a big problem. Now charging voltage limits and power limits. This is most important because you are using either a main grid or smart grid or microgrid for your purpose of charging, and what should be the highest voltage limits and higher power limits available to you as far as insulation and protections are concerned. That should be the standardized. If a vehicle battery needs higher voltage or power, the charger will not work. It's a normal thing. If your vehicle battery needs higher voltage, nothing else you can do except giving higher voltages. And if you go beyond certain limit, it becomes unsafe to charge your vehicle, because rate of charging is decided by the variety of battery, and you cannot go beyond certain charging rates. Okay. Communication protocols and lower voltages and power, that is also needs to be standardized. Communication protocols for energy operator and vehicle, both. Energy operator, I think those who are studying deregulation of power system, they might be knowing the independent system operator, that is ISO. So same energy operator is available either in autonomous way or in the physical way as far as your charging infrastructure is concerned. And that's why those protocol of communication should be standardized. And last one is the protection and safety requirements. Protection we will be discussing in detail. This is Indian standardization that we have moved upon till date. Okay. In 2017, we have started to concentrate, and Bharat chargers, the model and the capacity is written over here. At present, no communication to grid or to the vehicle. Medium power chargers are available, lowest power charger is available, and communication to grid is available as far as medium power is concerned, but protocols are not that much standardized. It needs to be standardized in accordance with the other countries. And DC001 protocol based on the GBT protocol for communication with vehicle. Still we are discussing, and many of the things are not finalized, because you know, once market is taken up in a big way, then standardization is feasible and possible. This is IEC standards. IEC 61851-1, same 21, same 21 by 1 by 2, 22, 23 and 24. And you can see the purpose, that conductive charging system is there. Second one is the EV requirements for conductive connection to an AC/DC supply. Third one, 21 by 1. It is EV on-board charger EMC requirements for conductive connection to the AC/DC supply. By 2 is off-board charger. 22 itself is AC EV charging station. 23 is the DC EV charging station. And 24 is the digital communication between EVSC and EV for control of DC charging. So these are the available IEC standards. Those who are interested, they may look at it first and then should start the research itself as far as challenges are concerned, because without knowing the standardization, you can't make initiation of the research, that why it is needed, how it is needed, and for what it is needed. If you are answering these 3 questions from standards, I think you will find something okay as far as your literature survey is concerned. And after literature survey, you may head up for any of the point we have discussed earlier. These are some countries where standards are there. You can see countries only. Standard body is SAE, IEC, JARI, GBT, BIS and DHI. Respective countries are US, EU, Japan, China, India and India. So last 2 deals with the Indian standards, and rest of the standards are available. So always you can compare Indian standards with the other country standards, and you can write a research paper as far as technological challenges are concerned. These are the standardized connectors. So if you have moved to the different countries, I think you may remember the basic plug designs or supply designs of a particular country. So nowadays, if you are traveling throughout the world, the universal chargers are available to you. Universal charger means if you are attaching, then you can use any plug throughout the world. And I think same terminology, same technology and same taxonomy is going on with these connectors. So when your vehicle is coming, it is having the, as you can mark on the left upper corner, it's a female and male connections are there, and that is to be used upon. Just below it, both has been shown. The EV socket is there, EVAC plug is there. US standard, EU standard and Japanese standards are available on the screen. As you can mark, said, then I am having this screen on board. Just you can study this. AC chargers are standardized in this way on AC 001, level 1, level 2, level 3. So up to 3 level, it is standardized starting from single phase to 3 phase, depending upon the capacity and current capacity. Okay. And DC chargers are available to you starting based on output, starts from 15 kilowatt, then 30 kilowatt to 300 kilowatt, and so on. So ultimately grades goes up to CCS1 and CCS2, where outputs are up to 1000 volt DC. And vehicle to grid standards as far as DC chargers are concerned. So these are the standards overview that you should look upon, and you can think upon that what should be done in this direction, because if all the standards are different, then it will be difficult to survive with the economy of inter-country. Intra-country is okay, but inter-country economics is somewhat different, and that has to be when you are talking about EV. So standardization is needed. Now the real block diagram is there. This is typical EV power system and charging models. So you can mark wireless transmitter and receiver is there, which is optional. Single phase and 3-phase onboard chargers are there. LV battery, HV battery to what functionalities are going on. This diagram may help. Now this is onboard and offboard charger configuration. The upper figure shows the onboard charger configuration. Lower one is the showing offboard charger configuration. So in upper figure, if you see from left to right, the AC which we are supplying, single or 3-phase, is passing through the charging station block. Again, it is AC when it is transferring to EV chargers. Level 1 and level 2 AC chargers are available on board to make it compatible. Then ultimately variable DC is the output. And by carrying protection circuit is goes to the battery by use of CC or CV charge. Again, battery monitoring mechanism is there in the feedback which helps you to charge your EV, and definitely it should be because it's a normal understanding of block diagram. So if you start from left to right, the second larger block shows you the onboard charger, and it starts from rectifier, gives you the fine DC for charging battery, and then things are moving. And monitoring, of course, is a normal parameter you have to deal with. Onboard charger. So level 3 DC chargers are there. As you can mark, again input is of level 3. So it's a higher capacity starting from 20 kilowatt to 240 kilowatt, and 3 phase is given. Variable DC supply is monitored and configured there. Okay. Charging stations are there in which we are doing this process, and then it moves to the larger block of level 3 DC charger. Again, same thing is available. Variable DC is available to you. By carrying protection circuit, it goes to the battery, and again feedback mechanism is there as far as your commercial purposes and technical feedbacks are concerned as far as monitoring and control is concerned. So this is what very simple block diagram is available to you. Now you can mark DC to DC converter is there in the upper block, upper larger block. Protection circuits are there. Okay. And battery monitoring mechanism is available to you. Safety interlocks are there in the starting as far as upper figure is concerned. On left block, a very small block is there, safety interlock. Okay. So these are the parameters to be researched, or you may say you can take it as a challenge and start to improve the performance from where they are at present, because this research area goes in long way. So now even to improve by 1% or 2%, that also is difficult. These are the protocols and charging. NPTEL only. So it's a CAN network in both the figures of CHDEMO and GPT. So you can mark CAN network is there, handshake mode is there, charging preparation stage is there, actual energy transfer takes place, and then shutdown or monitoring is there, and end of charging will take place. So physical interface is shown. As far as ISO 15118/2 is concerned, the power line communication in an older way. So that communication protocol is available, and how it works, that is shown. Handshake, their parameters and discovery, cable check, pre-check, current demand, power delivery, and welding detection. So these are the stages where power delivery takes place, and before that, it's a preparatory stage which you can mark upon. Now this is simple classification of onboard chargers, that is OBC. Again, taxonomies you must refer for the purpose of studying it. The onboard charger, either it will be single phase or 3 phase, as you can mark upon isolated and non-isolated. Isolated means it's a unidirectional, and then it is bidirectional. Again, it is conductive or inductive. Inductive means wireless, independent and integrated. So your base, if you look at the last line, your base is very large, starts from independent and integrated. If you take three-phase, again, same classification is available to you, and it ends in an integrated way. Now, inductive charging is somewhat seems to be difficult nowadays, but in coming time, I think this will only be available technology in the future. Just now we are moving through conductive because it's a initial phase. But as you know, technology is moving very fast. We are having mobile chargers in a wireless way. In same way, your EV may get charged in an inductive manner, and prices and prices mechanism will be digitally controlled. In fact, if you consider the future, you may note down that if two vehicles are standing nearby, or if they are passing nearby, they can know need of each other's, and if one is being exhausted as far as power is concerned, second one can supply it wirelessly, and the first can give charge to the second. So it's a earning while your vehicle is running. Only thing is they should move sequentially, and either they should stop, or in the dynamics itself, in the drive itself, they can exchange the power in an inductive manner, and prices mechanism will be set by the two parties. Because nowadays much research is going on the smart grid and everywhere, that buyer to buyer economics is playing important role. No, if you are my neighbor, you want to sell the power and I want to purchase the power, forget about the ISO. We should have our own price mechanism, and that price should be treated as final. Only ISO will give the technical sanction whether the excessive power from neighbor can be given to the first or not. And same mechanism, same price mechanism can be utilized for inductive or wireless chargers. So kindly note it that it may happen that your vehicle will be autonomously controlled, and when your battery is exhausted, you can purchase power while moving, and that will happen in the very near future, I must say. This is small detailed thing. The reference is shown. It's a paper by Vim Singh sir. A power factor corrected LLC resonant converter for electric vehicle charger using Buck converter. So easily you can imagine your block diagram which you have seen previously, and try to fit with the detailed figure. So at least the new researchers should know that block diagram is converted into circuit. Circuit is simulated, and then the results are being obtained. That is done by the many private companies in the sector of EV, and this is for the converter. It's a resonant converter for electrical vehicle charging. So as you can mark, the rectifier block, inductor, devices, and full the thing is managed in a sequential circuit, and lower one is the controller, and related mechanism is shown. LLC control is there on your right hand side lower. Okay, so you can mark with feedback it is working, and VG2, VG3 is the output, which is again utilized for your main circuit. So this is all together. You don't have to study at present in detail, just to show you that how thing works. I have selected this reference. These are the operating modes and switching waveforms as far as previous title was concerned. So you can mark your waveforms, switching waveforms, and mode of operation, mode 1, mode 2. So I'm not going into detail because for reference only I am showing you. If you are interested, I have shown reference here. That is from Bhim Singh sir in December 2019 with IEEE transactions. If you are interested, you can go to the reference and study it in detail. Again, this is e-bike charging application of PFC and ACPAC. Again, it is from same author in 2020. So almost you can mark is the digital PLL, voltage controller, frequency controller, current controller, and VCU is there. Again, VG2 and VG3 is the output that is to be utilized if you see in the upper circuit for gate triggering, and it takes input from voltage controller and current controller. So whole controllers are synchronized, and then final output is given to the devices in form of VG2 and VG3. These are again the waveforms of converter fed half bridge resonant converter. So try to understand the purpose of showing you this thing as a reference, because if you are interested in converter design or bridge design or rectifier design or controller design, these two references gives you the clear picture where your insertion should be. And that's why I'm showing you this. These are the parameters that are set upon. You can mark third harmonic current. It is 0.060 ampere. So this is what with these parameters you are doing this simulation. This is bridgeless PFC converter again for onboard EV charger. Now same terminology is there. Here outputs are VG2, VG3, VG4 and VG5. So you can mark the controllers, and with coordination of those controllers, it is given to the upper circuit, and it is bridgeless PFC converter. So again, I have kept reference from the same professor, because if you understand the 3 or 4 references, I think it will develop the insight that what is to be studied and in which way you should proceed. These are again the parameters and output. So we don't have to go in the detail because it's a reference only, and for reference only I'm showing it to you. This is solar based multifunctional EV charger. Now you can see after studying 3 references earlier, now we have started to insert non-conventional energy sources in form of PV array. So when you are inserting some non-conventional energy sources, things are different. Your input supply itself might be different than previous one, and how it affects the basic circuit performance that is to be seen in this reference. This is not that much useful. It's a flowchart of whole circuit. Only you should mark the things which is written on a red. This is V2H, V2G, again V2G at the lower side, and V2H. Okay. So these are 4 points that is being narrated, and for that thing I have kept this flowchart. Because it reflects the energy management and operating. As you can mark on the upper side, the grid available, yes, means grid connected mode. If it is not available, then it is islanded mode. So in islanded mode, you are utilizing grid connected. This is normally happens with every sort of small grid, whether you are utilizing it in a grid connected mode or you are utilizing in an islanded mode. This is solar PV array based on multifunctional EV charger. So how you are arranging the array, that is important to you. And these are the block diagrams where power flow goes or energy goes, and what is the mode of operation when you are charging with non-conventional energy sources. Need not to be solar array, but it may be any form of non-conventional energy source. This is again steady state performance in grid connected condition. Figures are small, so I think we should not find anything in this except the reference and effect of PV array. Because due to space and time limitations, this has been kept in a lower slice. So interested persons can go up to the reference and they can see it easily there. This is sweeping standards. This is one of two. It's a parameter on one side. One standard is 61815 3x3 and 62840. One is for LEV, one is for HEV. You can mark the rated voltages, its scope, series, and specs. This is AC chargers, that how AC chargers are working and what should be the basic cost related with your charging capacity and charger itself. If it is fast charger, you can read last two lines. 21 kilowatt fast charger. It may cost up to 50,000 for equipment plus 50,000 for power installation. And charge taken by charging station. So this is techno-economic factors that is to be considered if you are interested, because someone will be interested in only techno-economic factors, that what is the cost of charger, what is the cost of installation, what is the cost of unit. If I will be using non-conventional energy sources, how it can be reduced, and so on. So it's all together a different direction. Of course, technology is connected, but it's a techno-economic feasible study or feasibility study. This is for fast DC chargers. So you can see capital cost. Okay. And when you are reaching your breakup or break-even points, that is to be calculated, will need at least 2 cars to charge each day for break-even. That is written in middle, starting from 1, 2, 3, and 4th. 4th one you can easily mark that this will need at least 2 cars to be charged per day. Then you are reaching your break-even. If it is more, then you can start earning in a form of profit. This is purely for battery chemistry. So battery chemistry includes NCA, that is nickel, cobalt, aluminum oxide, lithium cobalt oxide, lithium manganese oxide, and nickel manganese cobalt. So on right hand side, you can see different examples has been given with the varieties of battery. Okay, Tesla is there, Apple iPhone is there, Nissan Leaf is there, and Tesla Powerwall is there. So how much utilization is there in a market as far as these battery chemistries are concerned? That is shown here. So at present, the things which are useful for iPhone, that same can be utilized in a near future for your electric vehicle even. So you can see combinations of Tesla and Nissan. Both is offering both battery chemistries are different, NCA and LM. This is again some basic peak price. 2010 to 2018. You see gap is being reduced, started from 22% to the 18% is 2018. And lower figure shows you the configuration of charging station itself. So lithium-ion battery is proven nowadays and for quite long time it will be utilized till good research is available in form of material and battery. This is main benefits of V2X. Again, techno-economic factors are concerned that if you have your electric vehicles, it can be utilized in form of energy storage, in form of emergency power, in form of giving power back to the grids. So many things are available with your EV. Just to connect or to reconnect it, the specific pricing mechanism, specific economics, and specific technicality should be available with your EV. And that's why the basic initial pricing of EV is going to increase, not it will be decreasing, but continuously it will be increasing. And at the same time, government should concentrate to give more and more subsidies if they want that more and more EVs should be on road. So it's all about V2G, V2L, V2H, and V2V. You can mark the points. Is written here that wholesale power market participation, decrease investment in new power plants. This all includes the socio-economic and techno-economic and macroeconomic factors. So if you consider anything, you can think a lot and then you can start to write. Now this is most important area where we have arrived, the protection of EV chargers, because ultimately, as I told you earlier, that if you are utilizing any system, any vehicle or any technology, if protection is not there, then it is useless. Always fear will be mounted and end users. So this is what about the strikes as well as against power fluctuations on the network side necessary. Now this shows the two-way, 1.5 crores of lightning phenomena has happened in India. So you can think of that what should be the seriousness of lightning strikes. Okay, at the same time, our grids at present are not that much pure because nobody cares about it. We want to develop our infrastructure, that's all. Power quality is a different thing, power reliability is a different thing. We are not paying for it. Only we are paying for the factors of surviving the grids. It means power factor and voltage limits and frequency limits. That's all. We are not paying anything else than this. If you marked your electricity bill, we are paying 5 to 6 taxes. But at the same time, on utilization, very less charging blocks are available to you. Charging means the revenue charging blocks are available to you. That is our billing style at present. So that's why it is written over here that against power fluctuations also, which happens in the larger grid, if your vehicle is grid connected, then it should be protected against those fluctuations. A direct hit by lightning strike is devastating and hard to protect against. But the real danger for electronic devices of all kinds comes from the resultant electrical surge. If you see, if electrical surge is being inserted one time in your whole EV or at the input, I think more or less many electronic component will be burnt out, or it will not be useful to you as far as normal working is concerned. So that's why that protection is much needed. And same electrical to the electrical charging stations also. So that is to be cared upon and that should be protected. Electric vehicle or electric circuit or station or power station, that should be protected against short circuit and faults. This is true for every station of electric. The IC part 1 to 4 of 62305. This is what the basic arrangement is. Transformer station is there. Then S3 and S4, that is strike to incoming services. And S4 is the strike near incoming services. S2 is the strike near the charging structure. So you can see S1, S3, S4 is there. EV charger is there and electric vehicle is there. S2 may happen at the end user, that is to your EV, at end of EV, you can mark it. Now this slide shows the solution against the transient and permanent over voltages. It means transient and steady state over voltages. So you can mark that protection against transient and permanent surges. To protect against type 1 transient over voltages, LSP has the FLP 25 series guarantees high protection against transient over voltages for power supply line at the entrance of the building, including those produced by the direct lighting discharges. So lightning discharges protection is to be done with FLP 25 series. It's a type 1 and type 2 protector according to the standards IC or EN. Its main characteristic is impulse current per pole. of 25 kiloampere and protection level of 1.5 kV. It is informed, it's formed by the gas discharger devices. It is science for the state of protection. And next is the SLP 40 series. If it is transient or it is steady state voltages. Now mitigating of challenges, almost we have discussed, but just to show you some glimpses. What should be there for the batteries? So this is digital application on map service itself. It is shown the aggregator models for charging stations, just like Ola, Uber, etc. So you can easily see where the nearby charging stations are available and what sort of charging facilities are available, what sort of enjoyment facilities available within that or nearby that charging stations. So as you can mark here, find more than 15,000 public charging points across UK. So they are economically strong and geographical area is limited. So they have gone up to 15,000. So I think our national highways and state highways will be covered in the near future as far as petrol pump charging stations are concerned. So one paper we have submitted recently on the electrical vehicle adoption challenges and barriers in India. This is a review paper submitted to Tailor and Francis, and many of the portion of this presentation, except 4 references from Professor VGEC, has been taken from the same paper. So I think I should stop here, and to summarize all my talks regarding this, I would like to tell you that number of things are yet to be discussed. For example, I will show you one paper, so easily you can identify that how to come up with it. Okay, it's a SDev. So one of my students was helping to this team, and they have designed this paper, distribution network planning considering the impact of electric vehicle charging station load. It's the same thing. The researchers, those are present here. Many researchers have shown the previous papers, where capacitor is to be placed within a radial distribution system. Now, same way, this is electric vehicle charging station and electric vehicles. So I'm keep on moving with the paper because it is on my screen. So just you can have a look that how to study this kind of whole the research study as far as EVs are concerned, right? So it's a distribution feeder basically, but what you are studying at that time and what you are studying at this time, it might be different. Here you are studying the voltage stability. See, this is basic example which we are dealing with, dealing since many years. Electrical engineering dealing with this simple problem. If you move further, just I am giving you the glimpse, nothing else. You are considering reliability. That was not on the older papers, but nowadays you have to consider it. This is also important. Harmonics at that time of capacitor placement, we were not considering. We were knowing the formulas, but technically it was not that much important. So now you are studying TSD also. This is impact of EV charging load on different operating parameters of distribution network. As you are knowing, voltage, current and frequencies are the operating parameters. So this is the example they have worked with. This is substation, radial distribution, number of loads are there. Now in this load, you are inserting charging load. At the same time, you can insert some charging stations with available NCS generating facility. So it may happen that net metering is 0, but still you are inserting some of the power from non-conventional energy sources. So again, it will disturb your basic parameters of distribution network. Just to sum up, I have shown you this particular reference. Otherwise, there is no basic aim of giving it to you. Now, this is EV charging effect or impact on the station load and reliability. So, reliability is altogether new parameter which is to be concentrated upon. So, those who are interested can go through this paper, this reference. You will come to know how we are affecting. Okay, this is voltage of weakest buses. This is base case 1, 2 and 3. So we are not discussing the details because I want to finish it within 2 or 3 minutes. So that's all from my side. Only I was intended to make you clear that still you can carry out the older study or older fashion research in new way. So only new parameters are to be understood, and power quality assessment you can make, power quality development, mitigation techniques you may take up on. And this was one of the example where you are mounting your new building in basis of the older base is available to you, only you are constructing new building. And I have not discussed here the related parameters of skill development and startups, because altogether this is not a subject area of today's title. It was technological challenges only. So at last I will give you my 2-minute suggestion, and I am closing down of sharing my screen. So you can easily mark that nowadays research is not only the things where the one individual plays an important role. It's an interdisciplinary team who is working upon a specific topic with knowledge of electrical engineering, dynamics, I mean aerodynamics and all that thing, chemical engineer. So you may think of a team, and team member might be anyone, those who can help you. So don't ever think that to this particular direction, and that is the big challenging task nowadays, to create the thinking worthy team. So always you should think better, and if you think better, definitely you will be having some directions and try to form a team, interdisciplinary team based on that. That will help you. So it's a team research. It's not a individual research. Only your thinking is important, and your designing of research orientation is important. Just what I have shown you in my today's presentation, you may take up a very little task. For example, battery recycling. So you will need a whole team to take that challenge, that how to recycle the battery. So at present, what is being done, how it is being done, what are the environmental impact at present, And if you suggest something by which it can be improved, then it is better. So I think individual efforts are good, but it is not enough nowadays. And you should go far and far away with your team. It might be of 2 people, 3 people, or it might be a team of 200 people. Don't mind, but it shows your research orientation about the technological challenges. Or I am not saying it's a challenge, but it's a barrier. When you are saying it's a barrier, definitely it should be overcome. If not today, but tomorrow it will be overcome. And that's why the technological advancement is being placed. Just in recent days, people are having space tourism for even 10 minutes. So basically, it's not a space tourism, but to go out of the first and second layer of Earth, what you call is a space. So moving there and coming back. So if you take a stretch of Ahmedabad to Anand or Rajkot to Junagadh and keep vertical, they have traveled by that much kilometers only on the upper side. But still, it's a tourism. So big business model is to be given to public. And public is saying it's a space travel. So okay, believe it. It's a space travel. So here my aim to convey you that whatever it may be the space travel or it may be the anything else, but it's a new business model and new business direction. And same thing is true for EV. So nowadays, only discussion on EV has been started. 2 to 3 models are available to you as far as four-wheelers are concerned. Tata is offering 2, MG is offering 1, and I think Mahindra was offering, but now they have stopped. So only 3 cars are available to you if you are interested. And it may happen within 5 years, 30 models will be available to you with different kinds of battery. So technology is moving very fast. Situations are moving very fast. And in fact, digital technology and IoT is also moving same time. Because before 10 years, nobody has think of that a one branch of civil engineering, that is transportation, and one branch of physics, that is electrical engineering, will come together to solve the problem. So before a decade, nobody has think about it. But nowadays it has become true that one civil guy will be there, which is master of transportation, will sit with you and he will tell that no, these are the black spots, this is the total distances to be traveled, this is the population vehicle, I mean vehicle population, and these are the road conditions. So what sort of EV you should prefer or not prefer as far as national interest is concerned, personal safety, human safety is concerned. These all factors are coming into picture. So in fact, this time was less. Otherwise, I have got one reference and discussions from transportation guy also. So they
Sir,
are also
sir,
researching.
sir, next speaker is expert is ready, so we have to conclude within 2-3 minutes. Thank you.
I am concluding in 30 or 40 seconds. So thank you and listeners. And I hope research will be in the genuine way and very fast. It will be moving. So thank you, coordinator, your team for organizing this course and inviting me. If somebody is interested, they may contact me directly. They can have my contacts from the coordinator itself. And thanking you all. Thank you very much. Just I am leaving this session. Thank you once again.
Now, if any query of any participant, please ask. Otherwise, we are now closing this session. So thank you very much, sir, for accepting our invitation and delivering lecture. Thank you very much, sir.
Yeah, thanks a lot.